Hello, good morning, students. I'm audible. Hello, hello.
Yes, sir, audible. Good morning, sir.
Good morning. Is my screen visible to you?
Yes, sir.
Okay, yes, fine. So we are today to solve the problem on the carburetor. Basic problem we need to solve so that any such kind of problem appears in the exam, you can solve it. This is the common problem which appears in most of the exams throughout India. Just I'm telling throughout India. Okay, so this is a carburetor. Just a few things about the carburetor you should know. I'm just telling you few things regarding the carburetor. So what is basically carburetor? So we have this a passage. This is a passage through which the air moves. Air moves. Why air moves from the atmosphere to the cylinder? So why the air moves from the atmosphere to the cylinder is that during the suction stroke, vacuum is created inside the cylinder. So now generally this part is connected. This part is connected to engine. I'm again telling this is connected to the engine. This is connected to the engine, and this is actually the inlet part. This is the inlet part. This is the inlet part of the engine. The inlet part of the engine where it is being connected. This is the inlet part of the engine where it is being connected. So this is the line diagram kind of just I am just showing you. So this is the inlet wall. I am just showing you this is the inlet wall. So if the inlet wall is open, so there happens to be suction stroke. If I this is a piston, if piston is moving towards the bottom dead center. This is a TDC, and if goes down it is BDC. The piston goes down, that means there is a suction stroke. So when there is a suction inside the cylinder, there happens to be vacuum. Again I am telling there happens to be vacuum created inside. Vacuum means pressure below atmospheric created inside the cylinder. So this is connected here to this passage. So this passage is connected to atmospheric air. So since atmospheric, this here you have got the less than atmospheric surrounding air rushes inside. So the researchers what they did is that so they again in this passage, a circular passage, the tube. This is the tube. This is the tube. You can see this is the tube. This is the tube. This is the tube. So a cylinder type portion. This is a tube. So the researchers were very intelligent to have a venturi in between. You can see this part as the venturi over here. You can see this part as venturi. So venturi over here. So therefore, as the air enters, why the air enters, we are very clear now. Since there occurs suction during the suction stroke, vacuum inside the cylinder, and this tube is connected. The tube of the carburetor is connected to the intake wall. There happens to be less atmospheric pressure inside the tube. So therefore, the surrounding air enters the this tube. So again, we have got a venturi where there happens to be pressure, that is less area at the venturi. This is the venturi portion where there is less area. So there is a less area. Again, a pressure drop occurs here. So there is less pressure over here and more pressure over here. Here you have got the fuel in the float chamber has got is subject to the atmospheric pressure. So fuel from the float chamber comes here. So air coming from the atmosphere, fuel coming from the float chamber gets mixed up. This air fuel mixture is sent to the cylinder that is during the suction stroke. So whatever air you are getting, it is air plus fuel in case of the SI engine. So this is, you can see the passage, the tube. This is a venturi. You can see this fuel tube which is coming from the float chamber. This is the float chamber consisting of the fuel, and it has got a float. So it has got a float such that, see, if the float rises, then this that is a needle wall enters the fuel supply and closes it. That means it doesn't need it, when the fuel is not needed. But once it goes down, that means the fuel has to come inside the float chamber to fill the gap. Just understand these things, okay? So you have got the choke also. The choke wall is also built in the system to make it as a modern component. It is a throttle wall. So when you are pressing the accelerator of the pedal, that means you are pressing also the linkages are pressing the throttle wall also, and hence you get more amount of air. More amount of air means more vacuum created over. So more vacuum created over here means more amount of fuel will be coming over at this place. Please remember these things. Okay. So this is the one I just want to mention. We go to our problem, which was there is there actually. We'll go to the problem. So this is the problem which we intend to solve today. So there is a simple jet carburetor is required to supply 5 kg of air. So you are required to find that is supply 5 kg of air. So ma, I can write here the value of ma. uh, ma as 5 kg of air per minute. So 5 kg per minute means 5 by 60. 5 by 60 in kg per second. Then 0.5 fuel. So mf is here. Mf is also here given 0.5. Sorry, 0.5 by kg per minute means 0.5 by 60 kg per second. It comes in the 60. So please remember that the values we need to convert in seconds if it is in minute. Then if it is in millimeter, you have to convert in meters. Centimeter in meters. So these values you have to do if you have to solve the problem SI. Then the density, specific gravity of the fuel is being given. So Hg of fuel is given as 0.75. So Hg of fuel. So generally Hg, if you want to calculate Hg of any fuel, so it is actually rho of fuel divided by rho of the water. So rho of water, Hg of fuel, it is 0.75. So 0.75 into water, if you multiply, so you will be getting the rho f value. Rho f can be calculated kg per meter cube. So this again has to, you should know how the rho is being calculated. Okay. So the specific gravity is 0.75. Already we already in air is initially at 1 bar and 300 Kelvin. So I need to write here air as P1 as 1 bar, P1 as 1 bar, and T1 as 300 Kelvin. So generally, see, if it is given in degree centigrade, you have to convert into degree Kelvin. If it is degree centigrade, so you have to add plus 273 so that you get in Kelvin. We calculate the throat diameter of the choke. So throat diameter at the choke at here we need to find out the value of. So it is mentioned choke means actually at the venturi. Actually it is actually this is choke is here, but the whatever air is being coming, it is choked at the venturi. And this portion is also called as choke. So this diameter at choke has to be found out. Diameter at the choke found out has to be found out this diameter. So if we suppose that this diameter, in the last class we have taken this diameter as d2 at the venturi. So here we suppose that we have got the value as d1. यहाँ पे जो value है, so this value we consider this as d1. ये अगर हम d1 बोलते हैं, so this value we take as d2. So this d2 has to be found out. So d1 is given, d2 has to d1 is also not given, but d2 has to be found out. Then for a flow velocity of 100 meter per second. So velocity at that point is given. So C2 is given as 100 meter per second. So at 100 per second, the value of C2 is given. We need to find out the value of D2. Velocity coefficient is given. So the velocity coefficient Cv is given. Cv is equal to 0. Cv, value of Cv is 0.8. Then the pressure drop across the fuel metering orifice is that of is 0.8, that of the choke, is whatever pressure we are getting over here. So at the choke, at the fuel meter orifice, it will be the pressure drop will be 0.8 of that. So if it is, I say P2, so P2 जितना भी होगा, ये जो P2 whatever you are getting, so at the fuel orifice, the pressure delta P will be 0.8 into P2. This should be made, this should be known to you. So we are required to find the value of D2. हमको जो निकालने का है, वैल्यू जो निकालने का है, so I'm just going for the solution now. So I need to find out the value of C2, that is D2, and to find the value of D2. and यहाँ जो है, ये जो वैल्यू है, ये जो वैल्यू है, यहाँ पे जो वैल्यू है, ये हमको D2 निकालना, डायमीटर एट द वेंचुरी, डायमीटर एट द वेंचुरी मुझे निकालने का है. So this value, diameter at the venturi, I can calculate if I know the mass flow of the air. So generally I know the mass flow of the air can be written as rho AC. Rho AC. So rho is the density, A is the area, and C is the velocity. We are taking C as the velocity. So at the inlet and outlet means at the venturi, I can write this as rho 1 A1 C1, also equal to rho 2 A2 and C2. So see, if I can calculate the mass of the mass of air that is being flowing is already given. The mass of the flow is already given. Already seen that mass of the air is 5. This is 5 kg by 5 kg. So 5 kg per second is 5 by 60. So 5 by 60 is known. So this value is known. So 5 by 60, I know this value. 5 by 60 is equal to, so these are the formula, these are the general formulas. So rho A1, I want to find that is D2. So D2 is actually you get D2, over here. So what, how I get D2 over here is that if I just find out pi by 4 into D2 square, and if I know these values, I know the value of rho 2, if I know the value of C2, I can calculate, and I know this value. So you can calculate the value of the D2. So rho 2 has to be calculated. Again, I just, what I write, I just divert this equation as, I write A2 C2, and 1 upon rho 2 is the specific volume V2 C2. Okay. So the mass flow already you know, ये mass flow तो हमको पता है. Then the velocity at that point, velocity जो है at that point is also being given. ये जो velocity है हमने निकाले हैं, दिया है यहाँ पे, C2 is also given 100 मीटर पर सेकंड, ये भी हमको पता है. देखो, दिस इज मास फ्लो, आई ऑलरेडी टोल्ड यू. ये जो वैल्यू है 5/60 है, ये तो 5/60 है. तो वैल्यू ऑफ दिस वन C2 इज 100 मीटर पर सेकंड, 100 मीटर पर सेकंड. And V2 and A2 has to be calculated. In the A2 we know it is that the value is D2. So this has to be calculated. That means we need to calculate V2. So how we can go for the calculation of the value of V2? हमको अगर V2 निकालने का है. So how we are going to find out the value of V2? So again, we know that P1 V1 gamma is equal to P2 V2 to the power gamma. So therefore, from this equation, I can write here V2 by V1 to the power gamma is equal to P1 by P2. So further, what I can write is that V2 by V1 is equal to P1 by P2 by 2 to the power 1 upon gamma. So it means that I need to find P1 by P2 and V1. So this, can we find V1? Because we can find V1 because we know the value of the pressure at inlet and outlet. We know that. PV इज इक्वल टू MRT, ये हमको पता है, PV इज इक्वल टू MRT अगर मुझे पता है, सो आई कैन राइट P1 V1 M1 RT1. So that means that I can write now P1 V1 by M1 is equal to RT1. So V1 by M1 is nothing but this is P1 and this V1 RT1. Okay. So P1 is already given to you. P1 is given as 1 bar. So 1 into 10 raised to power 5. I want to find V1. So sorry. Here I can just write now here into value of V1 is equal to R is 287 and temperature is 300 Kelvin. So I can find out the value of, you can just find out the value of V1 now. You can find out the value of V1 now. Find out the value of V1. So specific volume at point number 1, that is entry. So this value V1 comes out to be 0.86. 0.86 meter cube per kg. This I just know. So our equation, I am just again telling that in our equation, see V1 is known. Here we know the value of V1. I want to find value of V2. V1 is known, so P1 by P2 has to be known. If P1 by P2 is known, V2 is known. If V2 is known, I put the value of V2, I can get the value of A2. If I get the value of A2, I can find out the value of D2. So now, what I will do is that I find the value of P1 by P2. So basic equation that day we have just find out that from the steady flow energy equations, if we apply at section 1 and 2, that is entry of the carburetor, entry at the carburetor and at the venturi. So these sections are at the entry and at the exit. At the exit means at the venturi. Just I am just showing you the things again here very clearly. हमको कहाँ चाहिए, ये कहाँ चाहिए हमको, तो हमको यहाँ पे चाहिए. देखो एंट्री कहाँ पे है, सो एंट्री अगर यहाँ पे है, so here this portion is the entry and this portion is the, this portion you can see over here, this portion is entry and this portion is, ये जो portion है entry का है, ये वेंचुरी का. so इसमें मैं क्या बोलता हूँ, so इसको मैं क्या बोलता हूँ, this is 1 1, ये हमारे लिए क्या है, this is 1 1, this is 1 1 and this position is 2 2, this position is a 2 2, ये जो position है ये 2 2 है. Okay, so yes, so that portion I have just mentioned over here. Now we go back now to our positions. We go back to our positions. We need to find out, so steady flow energy equation at 1 and 2. So the steady flow energy equation at 1 and 2 has indicated us that the value of C2 is written as twice delta H, is twice delta H, is twice delta H. And what is twice delta H? Twice delta H is CPT, that is CPT1 H1 minus H2, so CPT1 minus CP of T2. This we know, this we know. So again, further what I can write here is C2, since the velocity coefficient is given now, so I have to write CV, velocity coefficient is given, into, so this has to be modified, because velocity coefficient is given. Since the velocity coefficient is given, I have to modify this value C2 CV 2 into in bracket CP T1, if I take inside, it becomes 1 minus T2 by T1, T2 by T1. Further, this equation can be converted into twice CP T1, 1 minus, so I can write this as P2 by P1 to the power gamma minus 1 by gamma. Gamma minus 1 by gamma. So now I can put up the different values over here, because I have got values. I need to find P2, that is P1 by P2. So I'll find first of all P2 by P1, then P1 by P2, C2. So C2 value already given 100. So writing 100, CV value is 0.8, writing C as 0.8, 2 into the value of the CP, CP is generally 1005, temperature T1 300 Kelvin, so 1 minus P2 by P1 to the power gamma minus 1 by gamma. Gamma minus 1 by gamma means it is 1.4 minus 1 by 1.4, and that too in square root. Again I am telling that too in square root. So only in this equation the value which is unknown is P2 by P1. If I calculate the P2 by P1 value, what I get now here as P2 by P1 is 0.912. 0.912. So if I am to find P1, P2 only, so P2 will be, this is 1 and this is 0.912, 0.912, okay, 0.912. So P2 value, what I will get is 0.912. So again, I want to tell you that P1 is the atmospheric pressure, P2 is the pressure at the venturi. You can find it is less 0.12 है, ये एक है, ये एक है, ये कौन सा प्रेशर है, ये जो प्रेशर एंट्री का प्रेशर है, ये वेंचुरी पर का प्रेशर है 0.912 बार. सो दिस वी हैव गॉट, जो हमको मिला है. सो व्हाट इज आवर एम इज टू कैलकुलेट, our aim is to calculate the value of V1 by V1 by V2 so that I can calculate the value of V2, because V1 we know, हमको V2 वैल्यू चाहिए, हमको चाहिए कौन सा वैल्यू, V2 का वैल्यू चाहिए, V2 का वैल्यू चाहिए. So further what I do is now here, so V2 I know that V2 by V1, V2 by V1 is equal to what is it, is P1 by P2, P1 by P2, P1 by 2 to the power 1 upon gamma. 1 upon gamma means 1.4. So V2 by V1 is given. See, the value of V2 by V1 is V2 you know. So this value of V1, I have to find the value of V1. I have only 0.86. I will write 0.86 now. 0.86. Then P1 by P2. So P1 by P2 means this P1 is 1 and this P2 is 0.912 to the power 1 upon gamma. That means it is 1 upon 1.4, 1 upon 1.4. Okay, just it's not point. This is 1. 1 upon 1.4. So the value of V2 you get, the specific volume at point number 2, you get 0.919 meter cube per kg. This meter cube per kg you get, meter cube per kg. So now it becomes very easy. See, it becomes very easy if you want to find out the value of the that is if I want to find out the value now. So here this value MA is A2, C2 and V2. So MA is known, C2 is known. If I find V2, I can find it. So again I write the same equation over here. That is MA is equal to A2, C2 and V2. So MA I already know, it is 5 by 60. 5 by 60 I write over here is equal to A2 means pi by 4 into D2 square. Pi by 4 into D2 square. Pi by 4 into D2 square. Pi by 4 into D2 square into the value of C2. The value of C2 already given. The velocity at point number 2 already known. So 100. This value is already known. And the value of V2 we have calculated 0.919. So from this I can get the value of D2. So D2 here comes out to be, diameter at throat comes out to be 0.0312, and this is in meters. So into 100 will give you 3.12 centimeter. So this is the value of the MA, and हमको जो diameter of throat निकालना था, जो थ्रोट निकालना था, diameter of throat, we needed to find out the value of the throat. So we are successfully finding the value of d2. So d2 is 0.0312. Yes, the next step, next in the solution was to find out जो भी है. So here we need to find out again the value of orifice diameter. Orifice diameter. So firstly, we want to find out the diameter of choke, which we have found out the orifice diameter. That is fuel orifice. Fuel orifice का हमको निकालने का है. We need to find out the fuel orifice. So again, he applying Bernoulli's equation. We apply Bernoulli's equation. We apply Bernoulli's equation at 1 1 and 2 2, and 1 1 and 2 2 means entry at the that is a carburetor, and 2 2 means the section at the throat of the venturi. So where there is the fuel orifice. So what I get is that if I apply that, so P1 plus the P1 by rho f is equal to this equation. If I write P2 by rho f, P2 by rho f plus Cf square by 2 and plus Zg. So if I just modify this equation, so I get P1 by rho f minus P2 by rho f and minus Zg is equal to Cf square by 2. So Cf, if I want to find out, I can write this as 2 and square root of P1 minus P2 rho f and minus Zg. This is the value of Cf. This is the value of Cf. So if I can find the value of Cf, I can that is Cf. Uh, Cf is this value. Okay. So now I write the another equation. I write the equation. If I find this equation, I write the value of. I want to find the value of the df. So the basic equation mf is equal to mass flow. I am again writing mass flow is a CDF AF, then rho f into CF, rho f into CF. This is the value. So CF value we know here. So MF value, mass of the fuel, that is being given 0.5 by जो दिया है mass value, जो दिया है mass flow of the fuel. Mass flow of the fuel अगर हम देखते हैं, mass flow of the fuel अगर हम देखते हैं, so if I just find out the mass flow of the fuel, so it is 0.5 kg per minute. 0.5 kg per minute. So what I can write here, MF 0.5 by 60. This is the mass flow of the fuel. CDF, the value of CDF, that is coefficient discharge of the fuel, it is 0.6. So I need to find out the value of AF. AF means pi by 4 into DF square. Then the value of rho f, and CF. So rho f, if I write here rho f, and if this value 2 P1 minus P2 in bracket rho f minus Zg. So this rho f, if I take inside, so this is crossed over here. So if I take now, ये जो है इसको अगर अंदर लेकर जाता हूँ, तो what I get now? So 0.5 by 60, again I am writing over here 0.6 into pi by 4 into df square into ये rho f अगर अंदर जाता है, so what I get is 2 P1 minus P2 and minus Zg rho f, and that too this in square root. P1 minus P2. So again, what I am writing here is that I want to find the value of P1 minus P2. I want to find out the P1 minus P2. So already I have told you that we have found out the value of P2. We already find out the value of P2. P2 का value हमने निकाले है. So P1 that is the pressure at P1 minus P2. If I want to find P1 minus P2, already find out is 1 minus 0.912. This is the value of P1 minus P2. But at the venturi, it is 0.8 times. 0.8 times this value. 0.8 times this value. 0.07. So if I am putting this value over here, if I am putting this value over here, this comes also be 0.07. So if I am putting this value, this U value or ZG, this is equal to 0. If I put this value of 0.07 over here, I get the value of DF. So DF here comes out to be 0. That is a 2 point. The last value I am giving in mm, you are getting over here. So this is the value which I have got.